friends, nice to meet you all. May we all always be given health, happiness and success. Let's go back to discussing other world-famous scientists. Enjoy watching.
Muḥammad bin Mūsā al Khawārizmī, in Persian, is an Islamic scientist who is an expert in mathematics, astronomy, astrology, and geography from Kufa, Iraq. Born around 780 in Khwarezmia in what is now Khiva, Uzbekistan, and died around 850 in Baghdad. For most of his life, he worked as a lecturer at the honorary school in Baghdad founded by the Abbasid Caliph Ma'mun ar-Rashid, where he studied natural sciences and mathematics, including the translation of Sanskrit and Greek texts. His first book, Al-Kitab al-Mukhtasar fi Hisab al-Jabr wal Muqabala, was the first to discuss systematic solutions of linear equations and quadratic equations. So he is called the father of algebra. Al-Khwarizmī also played an important role in introducing Arabic numerals through the work of Kitab al-Jami' wal Tafriq by Hisb al-Hind, which was later adopted as the standard number used in various languages and was later introduced as the decimal position numbering system in the world. West in the 12th century. He revised and adapted Ptolemaic geography as well as worked on writings on astronomy and astrology. His contributions not only had a major impact on mathematics, but also in linguistics. The word algebra comes from the word aljabr, one of two operations in mathematics to solve square notation, which are listed in his book. The words algorithm and algorithm are taken from the word algorithm, the Latinization of the name. His name is also absorbed in Spanish, Khwarezmio, and in Portuguese, algoritmo means digit. Little is known of his life, not even the location of his birthplace. Its name probably comes from Khwarezm/Khiva, which was in the Khorasan province during the reign of the Abbasids, now Khwarezm, one of the provinces of Uzbekistan. His title is Abu Abdullah in Arabic or Abu Jafar. The historian Al-Tabari named him Muḥammad ibn Mūsā al Khawārizmī al-Majusi al-Katarbali in Arabic. The term al-Katrabali indicates al-Khawārizmī came from Katrabul, a small town near Baghdad. About the religion of al-Khawārizmī, Tumar writes another designation for him is given by Al-Abar, al-Majusi. This indicates that he was a follower of Zoroastrianism. This may have happened to people who came from Iran. However, later in the book Al-Jabr he presented himself as a Muslim. In Kitab al-Firist ibn al-Nadim, we find a brief history, along with his writings. Al-Khwarizmī did almost all of his work between 813 to 833. After Islam came to Persia, Baghdad became a center of knowledge and commerce, and many merchants and scientists from China and India traveled to this city, which he also did. He worked in Baghdad at the honorary school founded by the Abbasid Caliph al-Ma'mun, where he studied natural sciences and mathematics, including studying translations of Sanskrit and Greek manuscripts. His greatest works were in mathematics, astronomy, astrology, geography, cartography, as a foundation, and later more innovative in algebra, trigonometry, and in other fields he was interested in. His logical and systematic approach to linear solutions, linear, and quadratic notation provides accuracy in the discipline of algebra. The name is taken from the name of one of his books in 830 AD, Al-Kitab al-Mukhtasar fi Hisab al-Jabr wal Muqabala in Arabic or summary book for complementing and balancing calculations. His first book, which was later translated into Latin in the 12th century. In his book, Calculations with Hindu Numerals, written in 825, he principalized the ability of Indian numerals to diffuse into Middle Eastern and later European numerals. His book translated into Latin, Algoritmi de Numero Indorum, shows the word algorithm to be Latin. Some of his contributions are based on Persian and Babylonian astronomy, Indian numerals, and Greek sources. His systemization and correction of Ptolemaic data on geography is a tribute to Africa and the Middle East. Another of his major books, Kitab Surat al-Ard, Landscapes of the Earth, translated by Geography, which shows the coordinates and basic locations known to the world, boldly evaluates the length values of the Mediterranean Sea and the locations of cities in Asia and Africa previously given by Ptolemy. He then headed the construction of a world map for Caliph al-Ma'mun and participated in a project to determine the layout of the Earth, along with 70 other geographers to create the map that was later called, Know the World. When his work was copied and transferred to Europe and Latin, it had a great impact on the progress of basic mathematics in Europe. He also wrote about the astrolabe and sundials. Kitab al-Mukhtar fi Izab al-Jabr wal Muqabala in Arabic, or the Book of Complementing and Balancing Calculations, is a mathematics book written in 830. This book summarizes the definition of algebra. The translation into Latin is known as Liber Algebrae et al-Muqabala by Robert of Chester Segovia, 1145, and also by Gerardus of Cremona. The book provides solutions for linear and quadratic equations by simplifying the equation to one of 6 standard forms, where b and c are positive integers. Square is equal to the root of x2 equals bx. Square is equal to the constant number x2 equals c. The root is equal to the constant bx equals c. Square and root equal to constant x2 plus bx equals c. Squared and constant is equal to the root x2 plus c equals bx. Constant and root equal to the square of bx plus c equals x2. By dividing the coefficient from the square and using the two operations al-Jabr, or recovery or completion, and al-Muqabala balancing. Al-Jabr is the process of removing negative units, roots, and squares from notation by using the same value on both sides. For example, x2 equals 40x minus 4 times 2 simplifies to 5 times 2 is equal to 40x. Al-Muqabala is the process of assigning quantities of the same type to the side of the notation. For example, x2 plus 14 equals x plus 5 simplifies to x2 plus 9 equals x. Several authors have published under the name Kitab al-Jabr wal Muqabala, including Abu Anifa al-Dinawari, Abu Kamil/Razala fi al-Jabr wal Muqabala, Abu Muhammad al-Adli, Abu Yusuf Almi, Ibn Turk, Sin bin Ali, Sal bin Bisr, and Arafat al-Es. Another book by al-Khawārizmī is on arithmetic, which survived in Latin, but disappeared from the original Arabic. The translation was carried out in the 12th century by Adelard of Bath, who also translated the astronomical tables in 1126. In Latin manuscripts, it is usually nameless, but generally begins with the word Dixit Algoritmi, as al-Khawārizmī said. Or Algoritmi de Numero Indorum al-Khawārizmī on Hindu art numerals. A new name was given to his work by Baldassare Boncompagni in 1857. The original may have been Kitab al-Jami' wal Tafriq by Isb al-Hind, Book of Addition and Subtraction based on Hindu calculations. 15th century map based on Ptolemy for comparison. His third famous book is the Kitab Rat al-Ar in Arabic, the Book of Sights of the World or Appearances of the Earth, translated by Geography, completed in 833, is a revision and refinement of Ptolemy's geography, consisting of a list of 2,402 coordinates of cities and other geographical places, follow the general development. There is only one copy of the Kitab Rat al-Ar, which is kept in the Strasbourg University Library. The Latin translation is kept at the Biblioteca Nacional de España in Madrid. The full title of the book is The Book of Approaches to the World, with cities, mountains, seas, all islands and rivers, written by Abu Ja'far Muḥammad bin Mūsā al Khawārizmī, based on a geographical analysis written by Ptolemy and Claudius. The book begins with a list of longitudes and latitudes, including weather zones, which describes the effect of latitude and longitude on the weather. By Paul Gallès, it is said that it is very useful to determine our position in a bad condition to make a practical approach. In both Arabic and Latin copies, nothing is left of this book. Therefore, Hubert Donicht reconstructed the map from the list of coordinates. He tried to find an approach similar to the map. Zij al-Sindhind in Arabic Astronomical Tables is a work consisting of 37 symbols on astronomical calendar calculations and 116 tables with calendar, astronomical and astrological data, as well as currently recognized data. The original Arabic version, written 820, is lost, but another version by the Spanish astronomer Maslama al-Majr 1000 survives in Latin, translated by Adelard of Bath, January 26, 1126. 4 other manuscripts in Latin remain in the Bibliothèque Publique Chartres, the Bibliothèque Mazarine Paris, the Biblioteca Nacional Madrid, and the Bodleian Library Oxford. Al-Khawārizmī also wrote on the Risala fi Istikhraj Tark al-Yahud Jewish calendar manual. It describes the 19-year cycle of intercalation, the law governing what day of the week the month of Tishri begins, takes into account the interval between the Jewish era, Adam's creation, and the Seleucid era, and provides laws regarding the longitudes of the sun and moon using the Jewish calendar. Similar to those found by Al-Birn and Maimonides. Several Arabic manuscripts in Berlin, Istanbul, Tashkent, Cairo, and Paris contain approximation of material possibly derived from Al-Khwarizmi. Manuscripts in Istanbul contain sundials, which are mentioned in the Fayhırst. Other works, such as the determination of the direction of Mecca, is one of spherical astronomy. 2 works contain about the morning, Marifat Essayat al-Mashriq fi Kul Balad, and the determination of the azimuth of the height of Marifat al-Samt min Qibal al-Irtifa. He also wrote 2 books on the use and assembly of the astrolabe. Ibn al-Nadim in Kitab al-Fayhırst. An index from Arabic also mentions the Kitab ar-Rumah/T/Book of Sundials and the Kitab al-Tariq of history books, but the latter 2 are said to have been lost.
Well, that's the story of the journey. Hopefully it will add insight, be an inspiration, and make us smarter. Thank you very much for listening and waiting for the next story. Bye bye.